Hi, Ms. Rankin back with you. We're looking at our flip book. Hopefully you do have your flip book with you still. If you don't, you can pick one up at the office. Or if you're getting things sent to you in a packet, you should have gotten one. If not, let me know soon so I can get one to the office so it can be sent to you. Should be another set of packets going out Friday. Okay, so we're looking at rectangles here. A rectangle is a parallelogram. So it does have the 5 parallelogram properties. So our first 5 properties here are the 5 parallelogram properties. Hopefully you're learning those. You need to study those. 5 properties of a parallelogram. By definition, opposite sides are parallel. Opposite sides are parallel. Now remember, and this is probably the thing that gave us the most difficulty, because we have opposite sides parallel, when we have our diagonals, we are going to have alternate interior angles that are congruent. Okay, our alternate interior angles will be congruent. Diagonal is a transversal, alternate interior angles are congruent. So parallel does give us that. Also, our opposite sides are congruent. Remember, we mark those with tick marks. So if this side is 5, this side is 5. If this side is 17, this side is also 17. Opposite angles are also congruent. Now, in the case of a rectangle, by definition for a rectangle, all 4 angles are right angles. So if this is 90 degrees, this is 90 degrees. So we're still meeting that criteria of opposite angles being congruent. Consecutive angles are supplementary. Supplementary, remember that means they add to equal 180. Well, what's 90 plus 90? 180. So we're still meeting that criteria. 90 plus 90 is 180. Okay, diagonals bisect each other. Diagonals bisect each other. So this, have to use 3 tick marks here because we've already used 1 and 2, is congruent to this. Now I'm going to hold off on my other ticks for just a minute. I'm going to jump down here. Not only do the diagonals bisect each other, but rectangles have a very special property in that the diagonals are congruent. So since the diagonals are congruent, not only is this half diagonal congruent to this half diagonal, but they're also congruent to this half and this half. Okay, so each half diagonal will be the same length. Okay, diagonals are congruent. This total length will be equal to this total length, and then also each half will be congruent. Okay, also, very special property for a rectangle is we have 4 right angles. Actually, let me go back to my green that I used. 4 right angles. Okay, so not only are our opposite angles congruent, but all 4 angles are congruent. Okay, so we have our 5 parallelogram properties, which hopefully we're learning. And then really, for the rectangle, we only have 2 additional properties. Okay, hopefully we're good on that. Let's come down to our examples. All right, I pre-drew the rectangles, but I did not label them because I want to re-emphasize. Quadrilateral RST, when we name this, we can start anywhere, go in any direction, but we must continue around in that same direction. Okay, it is a rectangle, so I do have 4 right angles. We have diagonals that intersect at point P. Angle RSU, that's this angle right here, is 3x minus 5. It's a little hard to see there. UST, that's this angle. Now be careful, on a rectangle, the diagonals do not bisect the angles. Okay, these are not congruent. This is 4x plus 4. Okay, so we have expressions for these 2 angles. What do we know about those 2 angles? Angle S, the whole angle, is a right angle because we have a rectangle. So these must add to equal 90. So combine like terms, set them equal to 90. So we're going to have 7x combining like terms. We've got a negative 5 plus 4 gives us a negative 1 equals 90. Add 1 to both sides. Whoops, that's a 1. So we get 7x equals 91. Divide by 7. X equals 7 goes into 9 one time. That gives us a remainder of 2, so that's 13. Hope that's right. Okay, come over to example 2. This is A, B, C, D. Remember, I can go in any direction as long as I keep going. It is a rectangle. We have diagonals. They intersect at P. AC, that is my whole diagonal, is 4x minus 13. All right, I'm not going to write that on my picture. That's a little difficult to do. DP is half a diagonal, is x plus 7. We want to find the value of x. Now, AC is a whole diagonal. I could divide this by 2. I do not like fractions or decimals, so instead of dividing this by 2, since this is an odd number, I'm going to multiply this one by 2, as much as I hate big numbers. I like decimals even less. So I'm going to say 4x minus 13 equals 2 of these, because this is a whole diagonal, this is a half diagonal. So 2 times x plus 7. Okay, my whole diagonal is equal to 2 half diagonals. So over here I have to distribute. This is going to be 2x plus 14, and then this side just comes down. 4x minus 13. Now I just solve for x. Subtract 2x from both sides. So 2x minus 13 equals 14. Add 13. 2x equals 27. Look at that, I'm going to get a decimal anyway. X equals 27 divided by 2. 26 would be 13, so it's 13.5. Okay, come over here to example 3. And I can start anywhere. Doesn't matter. Go any direction. I just got to continue in that direction. J, K, L, M. Diagonals intersect at P. They can intersect at a point named something besides P. They're just being boring. Okay, LP, that's half a diagonal. And MK, that's a whole diagonal. MK, my whole diagonal is 26. I can divide that by 2, right? So 26 divided by 2 is 13. So half a diagonal is 13. LP is half a diagonal. So the 3x plus 7 would be equal to 13. Hope everybody caught that and is good on that. Okay, if you've got any questions, send me an email about that. But your LP is half your diagonal. The MK was a whole diagonal, so I divided it by 2. So that means half a diagonal is 13. Subtract 7 from both sides. So we get 3x equals 6. Divide by 3. And x equals 2. All right, that's it for our flip book. So copy that down, and that will be your NTI for the day. Tomorrow we will look at a more formal notes page with some practice. Thank you. Take care. Wash your hands. Hope everybody is doing well.